Here we're asked to find the IROC, or instantaneous rate of change, for this equation at the x value of 3. So to do this, I'm going to go ahead and find 2 points. The point at x equals 3, and then also the point at x equals 3 plus h. So this here is going to give me an expression so I can find the average rate of change expression to help me with this. So first thing I'm going to do is plug in 3 in for x, which gives me negative 2 times 9 minus 4 times 3, which is 12. So negative 18 minus 12, which is an even negative 30. So here's my first point. My second point is going to get a little bit messier, so I'm going to plug in negative 2 times 3 plus h squared minus 4 times 3 plus h. So I'm going to simplify this. This is where people make mistakes, me included. So I get negative 2, 9 plus 6h plus h squared. When I do 3 plus h squared, I'm also going to distribute this to become negative 12 and minus 4h. And lastly, I'm going to distribute that 2 in there to get my final second point. Negative 18 minus 12h plus h squared minus 12 minus 4h. So last thing, I guess I will combine like terms. Sorry, I got one more here. 3 plus h negative, what is that? Negative 30. And then minus 16h plus h. Nope, not plus h squared. This is the same mistake I made last time. This is negative 2h squared. Negative 2h squared. Just double checking my work here to make sure I didn't make any other silly mistakes. Okay, that looks good. There's my second point. Here's point 2. This is point 1. Now to find the average rate of change function, I'm going to subtract my y values. So negative 30 minus 16h minus 2h squared minus a negative 30 all over 3 plus h minus 3 because I'm subtracting my two x values. When I simplify this, negative 30 minus another negative 30 cancels out. I'm left with negative 16h minus 2h squared over h. I factor out the h here, and the h's now go away and leave me with negative 16 minus 2h. This represents my average rate of change, but I don't care about the average rate of change because that talks about a secant line. Really what I want is the tangent line, which is this green one that approaches, that touches just one line here. To do that, I really want the h value, or the distance between the 2 points, to become 0 here. So I am going to take the limit as h approaches 0 of this average rate of change equation. So I'm going to plug in 0, which gives me my instantaneous rate of change, which is negative 16. So this here is my IROC, or the slope of the tangent line.